introduction about Sir's achievement and his profile. Sir is MSc Mathematics from IIT Bombay in 1992 and the Department of Atomic Energy. There is a board, National Board for Higher Mathematics, NPHM, and has achieved NPHM scholarship also during his MSc days. Sir has his research in algebraic number theory. Sir is a trainer for Mathematics Olympiad at national level. Sir is teaching Olympiad classes at RAM Foundation. RAM stands for Raising a Mathematician Foundation, and also a very prestigious Bhaskaracharya Ganit Pratishthan. So sir is taking Olympiad classes there. Sir is a coach for MSc, PhD entrance examinations like IIT, JAM, TIFR. Sir is a resource person for Madhava Mathematics competition at undergraduate level. Sir has given lectures on number theory, cryptography, IIT JAM classes, MMC in various colleges. Sir is author of docudramas on mathematicians for Akashvani. Sir is member of writers team for Kutuhal column on mathematics in Lok Satta in 2021. Sir is also a columnist on mathematics in Patrika by Marathi Vigyan Parishad. Sir is giving consistent guidance to various schools in setting up mathematics labs. Sir has a personal collection of about 10,000 books on various subjects and is a part of activities like running mathematics circle for Ram Foundation and total 33 years of vast teaching experience Sir is having in the field of mathematics teaching. Let's clap loudly. Show a picture of our Shri I'm sure that with his interaction, certainly we will get the benefit. Over to you, sir.
Yeah, thank you for inviting me here. Am I audible in the last page? Yes. So as you can see from my face, I've been teaching only mathematics. I can't do anything else. And I've been teaching number theory. So as far as Olympiad is concerned, there are four main topics: algebra, geometry, combinatorics, and number theory. I hope for other three already there are lectures. So I am engaging number theory. And what's number theory? So let's start with number theory. It's one of the most interesting topics in mathematics, and where we learn about properties of integers. And most of the time, we'll be talking of positive integers. So what are positive integers? Natural numbers, right? So 1, 2, 3, 4, talking numbers. 1, 2, 3, 4, and so on. So I will denote this set by n set of naturals, and set of integers we denote by z. We don't denote it by I. Okay, so that's the German name for integers. There were many German mathematicians who are influential in mathematics, like Gauss and so on. So we use the German notation Z. Stands for Zeilen. So what things we learn in Olympiad for number theory? They are topics from derivative number theory. So one talks of mainly divisibility. I define all these things whenever necessary. Then one talks of division algorithm, and division algorithm is something which you have learned right from your third course standard. Like suppose I want to divide a number by some number, not the number, and how do we divide it? Is that fine? So 22 by 7. How do we do that? How do we do that? So for example, if I write 7 folds are 28 and 22 minus 28 minus 6. Is that good? No. So what's wrong? What's wrong in that? So this is not quite correct, right? So what's wrong in that? What's wrong?
So we have taken 7 for the 28, but the dividend is 22. So we are subtracting it with a bigger number.
So this multiple should not cross 22, right? It should not cross 22, which means it should be, this should be positive or non-negative, right? Okay, yeah. Now suppose if I do it this way, 22 by 7, 7 to the 40, and remainder is 8. Is that good?
No, sir.
This is also wrong. Okay, this is also wrong. What's wrong now? Now this is smaller than 20.
So we have to.
Yeah, so remainder is bigger than this one, right? And even that's wrong.
So
Yes.
we have to take the largest multiple of
Yes,
7 that is lower
yes.
than.
Good, good. So I have to take largest multiple of 7, which gets subtracted from 22, right? So 22 by 7, 7 3 are 21, and 1 remainder. Is this good?
Yes, sir.
Yeah, so this is good. Okay, so which means my remainder, so more generally, more generally. If I divide A by B where B is non-zero, I get some quotient B into Q and subtract from A, and this remainder should be non-negative as you pointed out, and it should be smaller than this number, or if it is negative, I should say put mod of it. Is that fine? Mod of it, that's what the absolute value of number. Okay? Yeah. So like if suppose I have minus 7, still that should be less than mod of minus 7, that is 7. Fine? Yeah. So this is division algorithm. Then one talks of GCD, LCM, GCD, LCM, one talks of Euclidean algorithm to find GCD of two numbers. Right? Then as far as Olympiad is concerned, there are many number theoretic functions like number of divisors, sum of divisors, and so on. Okay. Then prime numbers, everyone must deal with prime numbers.
Yes.
Yes. Yeah. Good. Then fundamental theorem of arithmetic. In fact, it's just a big name. Essentially, every number is either itself a prime or if not prime, you can factorize as product of prime, and that's in a unique way. Right? Like for example, if I'm given 72, 72 is not a prime, right? There are many divisors, and you look at the smallest factor that is prime. So 2 into 36. Again, 36 is not prime, you go ahead. So it's 2 into 2 into 18. Yeah? So then 18 is again not prime. Go ahead, 2 into 2 into 2 into 9. 9 is not prime. So that is 3 into 3. And now you see they are all factors. So that's what as fundamental theorem of arithmetic. Every number you can factorize as product of primes in a unique way. So if I'm getting 3 2s and 2 3s, that's the only way I get it. Right? So that's what as fundamental theorem. Then there is something known as is due to Gauss modular arithmetic or congruence in number theory. Those who are doing little bit of polygons must have seen these notations.
Yes.
Okay. But I won't go to that part. I have to teach many things there.
Sir, what is Euclidean algorithm?
Euclidean algorithm is to find GCD of two numbers. It's again by division. Right? For example, suppose I have to find GCD of 100 and say 35. Divide 100 by 35. Find quotient, find remainder. If your remainder is 0, then this is the GCD. If remainder is not 0, again you divide by remainder to this earlier divisor. This you must have done in school. Yeah. Okay, so that's about the syllabus for or topics for number theory in Olympiads. Right? And there are some good books, reference books. Madam, can you take this little up?
Karna Swami.
Little up.
Yes, sir.
I want those reference books.
Sir.
No, those regular books. Yeah. Okay, so these are some reference books. If you want to start with number theory, nice book to start with is Elementary Number Theory by David Burton. And it's a very simple book. There are a lot of historical notes in that book. Another book. So when I first learned number theory when I was in BSc, and that time Burton book was not there. So it was not printed that time. And we studied through a little difficult book by David Burton. And another book which is for particularly Olympiads, number theory by Aditya Purvi. And when that book was written, Aditya Purvi was 12th standard student. So आपसे थोड़ा बड़ा था, 12th standard student. It's a very good book, and right from beginning up to advanced level, that works. So that's a nice book. And all these three books, they are freely available on internet. You can download. You can use soft copy. Yeah. So let's start with problems. Already problem sheets are given to you, right? There are 10 problems. We'll try to do as many problems as possible, but I won't rush to the solutions. We'll go slow, right? Yeah. So while solving those problems, I will keep commenting on the necessary number theory part. Right? Yeah. So let's start. The first one. First one. It's more like a puzzle. More like a puzzle. Only the notation may be little new to you, difficult to you. We want 6-digit number. So problem 1. We want 6-digit number. Read the problem carefully. Yes, and this is like a puzzle. Everyone can do it. Everyone can do it. Okay. So we want 6-digit number made of digits 1, 2, 3, 4, 5, 6. Each use 1. Each use 1. So no repetition. I can't use 1 twice or say 6 twice and so on. I have to use every digit exactly once. That is form 6-digit number. Right? So suppose that 6-digit number I denote by following. First digit I write as x1, second digit I write as x2, third I write as x3, fourth I write as x4, fifth I write as x5, and sixth I write as x6. Okay. For example, suppose I simply put 1, 2, 3, 4, 5, 6. So my x1 is 1, x2 is 2, x3 is 3, x4 is 4, x5 is 5, x6 is 6. Is that good? Is the notation clear? All of you? Yeah? Okay. Now condition says first part, this part should be divisible by 1. Okay, and 1 divides every number, so that's fine. Manipulate that. Then 2 should divide x1, x2, a 2-digit number. So 2 should divide 12, which also works at least for this example, right? 3 should divide x1, x2, x3. 3 should divide x1, x2, x3. So 3 should divide 1, 2, 3. Yeah. So whatever example I have written, it works for first three conditions.
2, 1, 3, 6, 5.
Next. Then 4 should divide x1, x2, x3, x4, which is not quite correct for my example. And 4 won't divide x. Okay, why? Why 4 won't divide?
The last two digits.
Yeah, so we are talking of test of divisibility, which we learn in quite early stage of our school day. So as far as 4 is concerned, if number is divisible by 4, if the last 2 digits, that part is divisible by 4. Now 34 does not divide 34, right? So 4 won't divide 1, 2, 3. Is that okay? Yes. Then 5 should divide x1, x2, x3, x4, x5. 5 should divide x1, x2, x3, x4, x5. Right? And 6 should divide the whole number. Okay? Yeah, so that is the problem. Now, suppose I want to consider any such number I have to place numbers 1, 2, 3, 4, 5, 6 and right place. Okay? What do you think? Which number I can safely put at correct place?
5 at the
Very good, very good. Yeah. So 5. Where should I put 5? At fifth place. Right? All of you agree? Because if at this place there is 5, then x1, x2, x3, x4, x5, this number will be divisible by 5. If my number should be divisible by 5, this number should be either 5 or 0. But 0 is not given. So I should put 5 there. Right? So we have fixed one place. 5. Okay? Let's play. Okay, all of you agree? So fifth place should be 5. Then, now we have to fix other places. There could be more than one answer, that's possible. Okay? Or there could be no answer, even that's possible. Right? Yeah. What else I can say? What else I can say? Very good, very good. So one more thing, second place, fourth place, sixth place. There should be even digits. Okay? This number is divided by 2, so x2 should be even. This is divided by 4, so it's also divided by 2, so this should be even. And whole number should be divided by 6, so that should be divided by 2, and which means this should be even. Yeah, good, good. So this should be even, this should be even, and this should be even. Right? But how many even digits are given? 2, 4, 6. So in some order, x2, x4, x6 should be 2, 4, 6. Right? Now we are left with what? This already we have used. So we are left with 1 and 3.
So, but when at x4 we cannot put 4.
Yes, yes. So that is. So which means at these two places, I should have 1 and 3. Right? So step by step we are fixing the positions, we are fixing the number digits. All good? Yeah. So suppose for example if I place 1 here and 3 here. So my number would be 1 blank, 3 blank, 5 blank. These should be given 2, 4, 6. Okay. Now what should I use next? So as some of you were saying, this number cannot be 2 or 6, cannot be 2 or 2. Right? Why? No, sorry.
Only 4.
It can't be 4. Right? So it can be 2 or 6. Can be 2 or 6. Right? What about this number? So yeah, so this number has to be divided by 3. And what is the condition for 3?
Only 2.
Sum of digits should be divisible by 3. Right? Okay. So what can I place here? Two words, right? 2 words. 1, 2, 3 will be divided by 3. 4 will that work? 4? No. 6? Huh? Oh, very good, very good. Yeah. So it comes to that answer. Yeah, good. So 2 words, right? 4 does not work. 6 does not work, right? So I have to place 2. Now we have fixed 3 digits. 1, 2, 3, or maybe 3, 1. And you see with 3, 1 again, there should be 2. There is no other choice, right? So number can be 1, 2, 3, or 3 to 1. I have to fix 4 and 6 now. This can't be 4, as you said. So this has to be 6. This has to be 4, 6. 6. And then there is no choice. I have to place 4 here. Is the whole number divisible by 6?
Yes.
What is the test for 6?
Sum of
Yes.
divisible by 3 and is even.
The number should be
So number should be divisible by 2. It should be divisible by 3. Right? Yes. Good. So for 3 we know the condition. Now for Olympiads you should always think like Why that test? So for example, why that test for 3 or even for 9? The sum of digits, if that is divisible by 3, number is divisible by 3. Sum of digits divisible by 9, number is divisible by 9. Why is that so? There should be some reason, some logic behind that. Okay? So for all you should always think of sense. These are simple facts, simple things. Okay? So next, for example, suppose I have number, what should I take? Say 369. Okay? 369. Now what is meaning of this number? This is 3 into 100 plus 6 into 10 plus 9. Okay? I can split this part as follows. So this is 3 plus 3 into 99. Is that good? 3 plus 3 into 99. That will give me 3 into 100. Okay? 6 I can split as 6 into 9 plus 6. Alright? Yeah. Plus this last number 9. And you see this part is nothing but what sum of digits. Plus whatever this part I can take 9 common. So this is surely divisible by 9. And therefore the whole number is divisible by 9 if the sum of digits is divisible by 9. Yeah, as simple as that. And you see same words for 3. Because this part is also divisible by 3. So same thing, same logic will work for 3 also. Yeah. So that is about test for 3 and 9. So what are the answers? Some girl wanted to say answers. So these are the two answers, right? Right? Yeah. Okay. So there are two answers. Two answers. Right? And the two answers are 1, 2, 3, 6 by 4, 3, 2, and 6 by 4. Right? We have explained with logic. One by one we have fixed positions. First fix 5. Right? Then fix even places. Then fix positions of 1 and 10. It would be 1, 3, 3, 1. Right? Then fix this number by test of representative for 3. Yeah? And fix the rest of the number. So these are the only two answers, only two numbers, right? Which satisfy that condition. And we have done it with logic. Is that right? Oh yeah. So next one. Shall we go ahead? So that's first one. Next one. That is given theoretical. If you don't want theory first, let's do further that problem first. Third one. We'll do third one. Let n be the smallest positive integer such that sum of digits is 2013. Yes, let me do third problem. We are doing third one. Let n be the smallest positive integer such that sum of digits is 2013. Okay? And question is, what is the sum of digits of number 5 plus 2013? N is a number. N is a number as small as possible, smallest one, so that the sum of digits generally this is denoted by S of n. So this I want to be 201. 201. Okay? And the question is, whatever that number, you get 5 times of that plus 2013. What is sum of digits of this number? Is the question clear to everyone? All of you? Question? Is that right? Yeah. This is from question paper PRMO 2013. And this is typical of Olympiad. Whatever that year of exam, same number, somewhere they use in the question, forming question. Okay? So, since there is 2013, surely this must be PRMO 2013 question. So, as you must have seen, first level now they call it as IOPM. So before Corona, it was named as pre-international national TR. Okay. So now the same exam they call it as IOPM. Yeah. So I want some number whose sum of digits is 2030. And I want it as small as possible. Let's take a small example. Suppose I want sum to be, let's say 10. Okay, if I want sum to be 10, there are many numbers whose sum will be 10. Like for example, if I take 1, 1, 1, 10 times, this is one number for which sum of digits is 10. Okay, any other choice? 5, right? Yeah.
7, 9.
Any other choice?
7, 9.
Now what do you think? If I want as small as possible, what should I use?
9.
I should use 9. Right? Yeah. So whether it's 9 1 or 1 9, what shall I say?
1, 9.
So smallest is 1 9. Okay? Yeah. So very first thing, as wanted by you people, so very first thing, use for smallest number, make use of digit 9. Right? So for example, if it is 10, I should use only one 9. But if it is 100, how many 9s I should use? I want something 100. What should be the smallest one? So if I use 9, that will give me smallest possible number. Right? If I use 9, that will give me smallest possible number. Suppose I want sum to be 100. What should be number?
11.
Yeah. So one answer is 11 9. All clearly 9 times. And plus this gives me 99 plus 100. Now that one I should put here. Or then this side. What is the larger? Sorry. What is the smaller? I should put that one instead of this. This side. Okay. So for all of the idea is clear. Okay. Now working for this number. So what should be that number? Sum should be 2030. Same logic. What is the word? Like for 100, to take 999 11 times, and there is one remainder. So I have to add one more, and that one I should place this side, so that I get smallest number. Is this logic clear to everyone? So how many nines you should get?
220.
Very good. So what we are using? Division algorithm, right? Division algorithm. 2030. And all of you know how to divide number by number. So I'm dividing by 9. 9 गुणे 18, 2, 9 गुणे 18, 3, 9 3 27, 7. Yes. So shall I say
The 6
2030
1 stand at 223.
is 9 into 223 plus 6. So I should use 223 nines
And 6
and
1.
1 6.
And the 1 6 will be.
Where should I put that 6? This side or this side? All of you agree? Yes. So number should be n should be 6 and I say 999. You put dot dot dot. You can write 2030 numbers and 223 numbers. Right? And I say this is 223 nines. That's my number. Okay? All right? Yes. Now we should find pi n plus 2030 and we have to find sum of digits. Okay? If I want to find sum of digits, basically I should find all digits. I should know what are all digits. Yeah? Think about it. Pi n plus 2030. The smallest n we have got, what should be pi n plus 2030?
For 2020.
You can work together, maybe in groups. Yes, no problem. Pi n plus 2030. I may not be able to write the whole number neatly, right? But I should know, understand what are the digits, right? Yeah.
Sir, this 5n comes as 1 0 0 0 0 0 3, then 222 times 9, then after that 5.
Great. I don't know that. We'll work. Okay. So 5 plus 2030 is 5 times
5
6,
9
99999, 223 digits. Right? Plus 201. Now to simplify this number. Okay. Now do we have to suppose for example 69 I can write as 70 minus 1. All good? 69 is 70 minus 1. 699 is 700 minus 1. 6999 7000 minus 1. And this number will be 7. Same number of digits. 0 0 0 223 times 223 times minus 1. Is that good? Yeah. Same number of digits minus 1. Okay? Plus 201. So at least I am getting some idea, some code on number of digits of pi n plus 2030. Yeah? So that is equal to, what shall I say? Pi n plus. So that is 35 and over 35, 223 zeros. 223 zeros. Minus 5 plus 2010. What is that? Minus 5 plus 2010.
2008.
2008. So I am getting nice complete idea of this number 5 plus 2030. Okay? Yeah. If I write here, can you see back side? If I write here, can you see that? Or shall I write somewhere? Yeah, I write this here. Okay. So 3 5 3, 5. I have all zeros, right? All zeros. And many zeros, 223. Right? So I can safely write last 4 digits as 2008. All zeros. That is my number. Okay, so n is what? 35. Then 219 zeros. And doesn't matter whether there are 1000 zeros, 100 zeros, doesn't matter. They won't add up to sum of digits. Right? So, yeah, so some zeros and at the end there is 2008. Okay? Yeah? So, S of this is S of 5 plus 2030. Apple.
18.
So, 8 plus 2, 10, 10 plus 8, 18. Yeah? Good.
Yes.
Afterwards, what you can do is, I mean, 2 days later, you solve all these problems on your own without looking in this notebook. Okay, that's the best revision. Fine? Yes. Shall we go ahead? Any doubts? Third problem? Come, let's go. Yes, let's go. I thought this is easy. That's a standard question. That is again from some IFM. Yeah, both is again little bit there are just one competition. Find largest or positive median and
The main
such that
then this fourth question is the remainder will be 0.
such that n plus 10 divide n cube plus 100. Okay, I'll give nice simple notation for divisibility and we'll use that notation. Okay, write down notation. So, if D divides number n, these are integers. If D divides n, and what it means by D divides n? Like for example, 3 divides 12, 4 divides 12, 5 does not divide 12, and so on. So, if D divides n, what's meaning? That is n I can write as D times some integer. Okay, some integer. So, like for example, 12 I can write as 3 into 4. 12 I can write as 4 into 3. 12 I can't write as 5 to some integer, right? 12 is 5 to 2.4. So we say 12 does not divide, 5 does not divide 12. Okay. I want some integer.
Then 6 into
Yeah. Then 6 divides 12 and so on. So if D divides n, we denote it as D vertical line n. It does not mean d by n or n by 2. Okay. So when I say for example 3 vertical line 12, it means 3 divides 12. It's not 3 vertical or 12 by 3. Okay? Yeah. So that's simple notation. With this notation I write such that n plus 10 divides n cube plus 100. Is the notation clear to everyone? This is not remainder. Give it to it. Remainder will be second. Give it. So perfect. Yeah, I'll also say 5 does not divide 12. You slash it. Okay, like for example, this is equal to this is not equal to. This is divide, this is does not divide. Yeah? Okay, so I'll solve not this problem, I'll solve similar other problems and one of you can come to the board solve this problem. Fine? Okay. Okay, so as far as this problem is concerned, for example, do you see 10 is one answer? 10. If I put n equal to 10, this number is 20. And 20 surely divides 10 cubes plus 100. Is that good? Okay? Yeah. What else? What else could be answered? So n equal to 10, I said one answer. I said one answer. Are there more answers? Are there more answers? Ah.
Sir, as in figure 20. Sir, as 20.
Yeah, 20 also will work, right? Now, out of all such various answers, we have to find the largest value of that. Okay, so our idea is following. I solve similar other question. Similar other question. Largest n such that n plus 10 divides say n square plus 100. Okay, now the idea is as far as this number is concerned, somehow I should get rid of n on this side. If I get some number that n plus 10 divides 100, then this side has fixed number and I can then talk about n plus 10. What's the largest possible thing? N plus 10 should be 100. That's the largest possible thing. Right? So if I get some number here, if I can get rid of n, if I can eliminate n, right, then I get the actual answer. So I should get some number here. Now for example, we need some algebra here. Some algebra. Do you all agree that n plus 10 divides n square minus 100?
Yes, sir.
Right? N plus 10 into n minus 10. Okay? So I know n plus 10 surely divides this in any case, and we have given that n plus 10 divides this. So n plus 10 should divide this minus this, and that will cancel out n square. Is the idea clear? This minus this. So n square cancel. 100 minus 100, they would cancel and get 200. So n plus 10 should divide 200. And what is the largest such number? 200. What is the largest divisor of 200? 200. Right? So n plus 10 should be 200, which means n should be 190. Is this idea clear to everyone? Okay. Now, just on the same idea, try to work this problem, and somebody please come to the board and solve it. All fine? Wait for 2 minutes. Let everyone do it. So we need some algebraic formula. Then that becomes easier. Huh? Or even something better than that. You can say a plus b divides a cube plus b cube. So that will be d. So that makes it easier, right? Yes, so if everyone has got some answer, let him come to the board there. If you want time, I'll wait for a minute. English is written but why do you say infinity? Here this one if you want. Okay, so n plus 10, so divide n cube plus 100, you have to find largest such n. One answer I gave you, which is small one, n equal to 10. And he is giving largest possible value of n, such that n plus 10 divides n cube plus 100. Okay, again, a little bit of algebra, a plus b divides a cube plus b cube. Okay? Okay? So same thing is using n plus 10 divides n cube plus 10. Second n cube plus 1000. And we are also given n divided n plus 10 divides n cube plus 100. Subtract n cube and cube will get cancelled. That's the main point. You try to cancel out n so that you get some number. And so you get n plus 10 to divide 900. And what is the largest value of divisor of 900? 900. Right? So n plus 10 must be 900, which means n should be 890. Okay? Yeah. So largest value of n is 890. आपको समझ आया? आइए. Let us do an example. I mean, to explain the idea, I'm taking something different. Yeah. So again, this is in terms of n. So I get n plus 10 divided some expression which is again n in terms of n. Suppose I get some number like n plus 10 divides 200. Then slowly I can talk about it. So what's largest value? Largest value would be 200. Right? So that would eliminate n. That is that. Right? How to say that? So like for example, by multiplying a plus b divides a square minus b square. Always. So what is the n plus 10 is always divided. And we are given n plus 6 to divide. This is given. So I can say n plus 10 divide this minus subtraction. So n square n square cancel. And 100 won't cancel. 100 minus minus 100. This is the basic idea. Same thing will be here. Only the formula is for Q. Yeah, shall I get this? Very good. So we are doing fine. Question number 5. 100 students, it's more like a puzzle, but that's a nice question. 100 students are standing for a parade. Okay. Their NCC teacher orders them to sit down. That was first command. Right? Always standing, sit down. That's first command. Okay. Next, he orders every second student to change the position. So later on, second, fourth, sixth, eighth, and so on, they are changing positions. Right? So after second command, yeah, they can take their hands down. I'll come to you. So after second command, 1, 3, 5, they are all sitting, right, according to first command. And every second person, 2, 4, 6, 7, will change the position. So they'll stand up. Okay? Then third command, third order, every third student should change the position. And so on. Right? I don't know whether in NCC really they do like this. I was never part of NCC. But in one problem, there are 100 such commands. So if you do it 100 times, after 100 such orders or commands, who will be sitting and who will be standing? That is the question. Okay. You first try it, think about it, and then we will come to solution. If you want, I can show that position. So first step, I mean, zero step, step 0, initial condition, all are standing, 100 students, 100 students, all are standing. First command, step 1, make everyone sit. So each of them is sitting. I'm not good at drawing, so they are all sitting now. They are sitting. Step 2, second command, every second person should change the position. So first will be as it is, second will stand. Third will be as it is, fourth will stand. Fifth as it is, sixth stand, and so on. 99 will be sitting, 100 will stand. Okay, that is after command 2. Command 3, every third person will change position. So step 3, person number 3 will change the position. So he will be standing. 4, standing. 5, 6 was standing. 6 will sit down. And so on. If you want, instead of 100, you can try with 10, get idea, and say something for 100.
Numbers which are the square will have odd number of divisors. Therefore, they will have odd parity, whereas others will have even parity.
Is the problem clear to everyone? So think about it. Interesting like a puzzle. But that talks about some simple number theory. If you are afraid with 100, maybe you can track also with 10. And yeah, so then you can actually draw and work there. And then you can predict for 100, guess for 100. हाँ, so 1 to 100 में से कौन-कौन खड़े रहेंगे at the end of 100 को command और कौन-कौन बैठे रहेंगे? It's some early or I Okay, those who have got answer for this question, maybe you can try from question 6 to 10, something from 6 to 10. Okay? So let's focus on small numbers 4, 5, 6. Student number 4, student number 5, student number 6. Yeah, student 4, 5, 6. Fine. Now student number 4, when he or she changes the position, first step sitting, okay. So 4 persons. Student number 4, right? Step 1, sit, right? Step 2, every second person. So 2, 4, 6, 6. So 4 comes there also. So second step, it will he or she will stand. Right? Step 3, no change. Right? Every third person. So third, 6, 9, and so on. 4 person won't change position. And step 4, he or she will again change the position. Right? So person 4 changes at step 1, step 2, step 4. Is that good? He or she won't change at step 3. Right? What about person 5, student 5? Changes at number 1, step 1. Second, does it come in table of 2, 2, 4, 6, 8? So 5 does not come. Right? Third, step 3, no. Step 4, no. Step 5, so fifth will change position. So fifth person changes position at step 1, step 5. Right? Sixth person will change position at step 1, step 2, step 3, not at step 4, not at step 5, step 6. Right? And what are these? What is it? The divisors of 6, divisors of 5, divisors of 4. Right? And moreover, say if it is 3 times, sit, stand, sit. Right? If it is 2, sit, stand. If it is 4 times, sit, stand, sit, stand. Right? So if number of divisors is odd, is odd, then you sit and sit and so you sit number of divisors is even, you stand. All agree with that? All of you agree with that? Yeah, so question is related to number of divisors. Given any number, say n, how many times that person changes position? As many times as number of divisors, right? And if there are odd number of divisors, person will be sitting and again, and if there are even number of divisors, person will be standing. Okay. Yeah. So the question, I said half the answer. So which persons have or which numbers have odd divisors and which numbers have even divisors? It depends on that. That will decide who are standing, who are sitting. Okay? What do you think? Which numbers have odd divisors and which numbers have even divisors? So, like for example, like 4, 5, 6, 4 as odd, 5 as even, 6 as even. Right? You look at divisors, divisors always occur in pair. Divisors occur in pair. Okay, so for example, if we have a small number, maybe 20. Okay, 20 is what? 1 into 20, 2 into 10, 4 into 5. That's it. And you see there are even number of divisors. Right? Even number of divisors. Fine. Suppose I take 16. 16 is what? 1 into 16, 2 into 8, 4 into 4. So how many divisors are there? Now you see this, it's a perfect square. So this gives me only one divisor. Right? So number of divisors is odd. Even plus 1. So squares always have odd divisors. Squares always have odd divisors, odd number of divisors, right? And non-squares have even divisors. Non-squares have even divisors. All good? Everyone? Okay. So which numbers will be sitting square numbers, right? And then out of 1 to 100 will be sitting 1, 9, 16, 25, 36, 49, 64, 81 and 100. Yeah, let's go ahead. Next one. Yes. So now our problems are becoming little rigorous. I won't say difficult, little rigorous. Find prime P and Q. Find prime P and Q. Such that P square minus 2Q square is 1. Everyone knows what is prime? What are prime numbers? So exactly two divisors, 1 and itself. Right? So like primes are 2, 3, 5 and so on. Okay? Who are the even primes? There is only one even prime, 2. Rest all are odd primes. Odd prime? Yeah. Now this is the equation, right? And it is what type? So it's of the type x square minus some number t times y square equal to 1. Such equation is known as Bell's equation. Or let me say something something more precise, is wrongly attributed to 12. Almost 1,000 years before when it was done by Indian mathematician Brahmagupta. So let's call it Brahmagupta Pell equation. Okay. This kind of equation is called as Pell equation. Brahmagupta Pell equation. So at least given problem is simple because in this condition PQ should be given, PQ should be prime. So it's more easy. But we have to see the logic at every step. Right? So how shall we solve it? Like 2q square I can take to one side, 1 I take to one side. All are looking here? Yeah. So 2q square is b square minus 1. Okay. Now b square minus 1 gets factored. B minus 1 into b plus 1. Now you just play with parity. Parity is even or odd. Okay. So you see, LHS left hand side is even number because it is 2 times something. Right? 2 times q square. So LHS is given, and there are 2 factors inside. Right? So which means at least one of them should be even. At least one of them. But they differ by what? 2 places. B minus 1, B plus 1. So do you see parity of both of them should be same? Right? So which means one of them should be even, but if one is even, other is also even. Right? So both must be even on this way. Okay? So I said 2 divides LHS, 2 divides LHS, and 4 divides RHS. 4 divides RHS. Right? So I can cancel out 1, 2, 2. 1, 2, 1, 2 on both sides. Still there is 2 left here, this time. Are you following? Are you following? So this side is even. So both of these must be even. Right? I can't have one even, one odd. They are alternate numbers. Right? So if this is even, this is even. And which means I can cancel out 1, 2, still there is 1, 2 left. Right? So I should say, after cancelling 1, 2, 2 divides q square. All agree with this logic? 2 should divide q square. Okay. But if 2 divides q square, I can say something about q. So q square is given. Q square is given, which means q is given. Okay. And only given prime is 2. So q must be 2. Let me know how many times. Yes, so once I know value of q, I can put it here, I can get p. Right? So p square minus 2 into 4 is 1. P square is 9. Is that good? P square is 9. P is prime. So p must be. Yeah. So p equal to 3 and q equal to 2, that is the answer, that is the solution. Now there is one more interesting result, and this is the example for that. If I put values of p and q, what I get is 3 square, p equal to 3 square minus 2 into 2 square is 1. Okay? Or if I simplify further, 3 square minus 2 cube is equal to 1.
Into 1 cube.
And these are the only two numbers for which the powers differ by 1. That's the result due to Catalan. So this is result due to Catalan. In fact, it is interesting story about the result. Catalan conjecture in 1844 that only powers which differ by 1 only powers which differ by 1 are 3 square minus 2, right? Have only solution 3 square minus 2 cube equal to 1. What is the conjecture in mathematics? Conjecture is a result which is guesswork by some mathematician. The result is neither proved nor disproved. Right? So nobody proved it, nobody disproved it. When Catalan guessed it, so this was published in a mathematical journal called as Great Journal. It was published in Great Journal in 1844. And very recently, in 2004, it was proved in same journal. So that journal, after 150 years, still it's functioning. So, Pranata minus Q. I don't know how to pronounce it. Proved it. Now it's not a conjecture, it's a theorem now. Proved it in same journal. Same journal in 2004. So you see, as far as mathematical results are concerned, simple results like this, right? They need more than 100 years, in fact 160 years to get proved. So after conjecture, it was unproved for almost 160 years. It was proved after 160 years. Okay? Yeah, so that is one thing. Another thing about solutions of 10 equations are following. So let me solve x square minus 2y square equal to 1. Of course, we will get all solutions. I am not talking about price. Right? So all solutions. So I can write this as x plus 2 root y, sorry, x plus root 2y into x minus root 2y. Is that good? X plus root 2y into x minus root 2y. And if I take any power, like square, cube, any x power, that will simply be 1 this side. So that gives me in fact infinite many solutions. Okay? Infinite many solutions. So for example, look at 1 plus root 2 into 1 minus root 2. That is minus 1. Minus 1. So if I get even powers, this side I get always plus 2. Right? So for example, let me square it. What is that? Can you do 1 plus root 2 square? 1 plus root 2 square? Can you do that? What is 1 plus root 2 square? 1 plus root 2 square plus 2 times 1 into root 2. So this is 3 plus root 2. 3 plus root 2 into 3 minus root 2. That is 1. So 3 2 is one solution for answer to be 1. So, and that is the smallest one. So that corresponds to price. Right? So 3 2 is one solution. In fact, if you want all solutions, you can go ahead by squaring this number. Right? So for example, if you square it further, Square of this will be 9. 9 plus 8, 17. 17 plus square root 2 into 17 minus 2. That is again 1. So 17 square is 1 more question. Check. 17 square minus 2 times 12 square. That is 289 minus 288. 1. That is 1. Okay. So that's something interesting about Pell's equation. Another thing is continued fraction for root 2. Continued fraction for root 2. That gives me all solutions. So let's say root 2 is 1 plus something, right? 1 plus what? Root 2 minus 1. Is that good? Root 2 is 1 plus root 2 minus 1. Yeah? Is that fine? Yeah. So this is equal to, I'll rationalize 1 plus root 2 minus 1 into root 2 plus 1 upon root 2 plus 1. What do I get on the numerator side? 1. So it's 1 by root 2 plus 1. Shall I erase this part? Yes, sir. So this is 1 by root 2 plus 1. Right? 1 by root 2 plus 1. And now I replace this root 2 again and again by the same number. Right? So this is 1 plus 1 by 1 plus this root 2 I write as 1 plus 1 by 1 plus 2. I replace root 2 by same number again and again. Are you getting my point? I'm saying root 2 is 1 plus 1 by 1 plus root 2. Right? And this root 2 again I replace by same thing. 1 plus 1 by 1 plus 2. Then again this root 2 I replace. So that's why I get continuous fraction, infinite continuous fraction. Somebody wanted infinity there. So this, when I simplify, this turns out to be root 2 is 1 plus 1 by 1 plus 1, 2 plus 1 by again 2 plus 1 by 2 and so on. Infinitely. Okay. So if you work at up to some finite step, that will keep on giving you solutions. So first case, or I mean first convergent 1 plus 1 by 2, that gives me 3 by 2. And that gives me solution 3. Okay. Next one would be 1 plus 1 by 2 plus 1 by 2. So this is 2 to the 4, 4 plus 1, 5 by 2. Again I simplify, so this is 1 plus 2 by 5, 5 plus 2, 7, 7 by 5. This will correspond to minus 1. So 7 square 49 minus 2 times 5 square, but that corresponds to minus 1. Right? All evens will correspond to plus 1. Yeah. So continuous fraction gives you all solutions. Okay. So that is about Pell's equation. In fact, there is a rich theory of Pell's equation, and there is a lot of history regarding Indian mathematics, like Brahma and so on. Yeah, next one is simple, but that is again connected with one more condition, number 3. 2, 6, 1, 7, 1. 2, every integer n greater than or equal to 12 can be expressed as sum of two composite numbers. Sum of two composite numbers. I will remark on the question and then you can solve it. So that is in fact corresponding to one famous, well-known conjecture in number 8, known as Goldbach conjecture. This is exactly opposite of Goldbach conjecture. Yeah, so Goldbach conjecture says every even number, every even integer greater than or equal to 4 can be expressed as sum of two primes. Can be expressed as sum of two primes.
So can you prove this?
No, that's
क्या कुछ भी
they are checking the confidence of 4 into 10 raised to 18. There is no confidence. Yes. No. This is unsolved. This is conjecture. And it's unsolved for many years. So exactly opposite in nature is this problem. Like here, every even n can express as sum of two primes, and here question is every integer can express as sum of two composites. So is the question clear? I should take till what 12:45. What's the time for
So
this
12:45, 12:45.
Yeah. So we'll complete this question and we'll stop for today. Tomorrow I have one more session and we'll solve some more problems to tell me more detail. So all of you, 10% from this is homework. 10%. So that is one old I question. That is interesting. Yes, somebody wanted to do it by induction. Have you got my induction? Actually, one could make it without induction. So, like make it an even and an odd. Suppose if n is even, right? Then n I can break it as 4 plus n minus 4. 4 plus n minus 4. Okay? And what is n minus 4? Again even. Right? So this is even. And at least 8. At least 8. Right? Okay? So this is again composite. So composite plus composite. Good. And if it is odd, I can break it as 9 plus n minus 9. What can I say about n minus 9? N minus 9 is odd minus 9. So that is again even. And it is even at least greater than 2. Right? So this is composite plus again this is composite. Yeah. So you can do it without induction. Make cases even odd, right? If it is even, you write it as 4 plus something or 6 plus something, right? And so they are both composite. And if it is odd, you write it as 9 plus 10 minus 9. But this is again even, odd minus 9. That is even, right? Greater than 2. So this is again composite. So I think, shall I start the Sir, can I do one problem? Time? Yes. Okay. Gate 1. Find 20, 25 positive integers. 20, 25 consecutive positive integers, none of which is prime. Okay? So that talks about gaps in prime. Look at gaps in prime. Say gaps in prime. Say 2, 3, 5, 7, 11, 13, 17, 19, and so on. So you see, there is gap of 1 here, there is gap of 2 here, there is gap of 2 here. Gap increases, that is 4, again it reduces, that is again 2, right? This increases, again it reduces, 2, it increases, right? Further it still increases. So the gap between two primes is irregular. That's the point. There are many methods regarding this. So, but at many places you get gaps between two, right? So you can always get somewhere primes of the form P plus. If both are primes, they are called as twin primes. Twin primes. So the gap reduces at many places, and it has been proven that there are infinite like twin primes. So how many such pairs are there? Infinite. Okay. But whenever I wish, I can find say 4 consecutive numbers, none of which is prime, all consecutive. Or if I wish, somewhere I can find 10 consecutive numbers, all of which are composite. Right? So I want, question is, I want 20, 25 consecutive numbers, all composite. Consecutive numbers, all composite. So meaning thereby somewhere gap between two primes is more than 20. Right? So gap is as large as possible, as you wish as possible. Okay. So for example, if I want 6 consecutive components, suppose if I want 6 consecutive components, can you give me example? 6 consecutive components. 19, yeah. Or I think smallest one is maybe this one. 24, 25. So you get near S. 90. So 90, 91, 92, 93, 94, 95. So you get 6 consecutive, 7 consecutive, 8 consecutive. Like this, if you want, you can produce 100 consecutive composite numbers. You can produce somewhere 20, 25 consecutive composite numbers. That's the question. So I'll explain the idea and work over that and we'll stop there. So what are consecutive numbers? They are the form. Consecutive numbers are the form. Say n, n plus 1, n plus 2, n plus 3, n plus 4, and so on. Right? Okay. So I forget first two. I focus on n plus 2, n plus 3, n plus 4, and so on. So if my number n is such that it is divisible by 2, then this number is divisible by 2. Okay? If my number, so if 2 divides n, 2 divides this number, which means it is not prime, it is composite. Right? If 3 also divides n, then 3 will divide this number. So this is also composite. If 4 divides n, this is also composite, right? So I want my n such that every number like 2 divides it, 3 divides it, 4 divides it, and so on. Like that, I want 20, 25 numbers. Okay. So maybe I should try. So, product of all these numbers. So maybe I should try n equal to, that's called as factorial. I hope everyone knows factorial. So maybe I start with, I change this one, 20, 25 factorial plus, right? N equal to 20, 25 factorial. So if I put it here, this will be divided by 2, this will be divided by 3, this will be divided by 4, up to, I can safely say up to 20, 25. Right? But these are how many numbers? It starts from 2, not 1. So these are basically 20, 24 numbers. 20, 24 numbers. Right? So I should change a bit. I can make it 20, 26. Can make it 20, 26. And you see these are 20, 25 numbers. Each composite, none of them is prime. This is divisible by 2, this is divisible by 3, this is divisible by 4, and so on. Up to this is divisible by 20, 25, this is divisible by 20, 26. So none of them is prime. They are all composite and consecutive. So you can find a gap of 20, 25 numbers, right, between two consecutive primes numbers. Yeah, that's the idea. So we'll stop for today. Thank you. Tomorrow I have one session and we'll do more rigorous problems.
Good afternoon, sir. I am Anjor Shrivastava from class 10. I study in ACS2 Mumbai. Sir, this was a really interesting session and we were introduced to a relatively new topic of number theory, which is really important for IUPM and for subsequent mathematics Olympiad levels. Sir, the problems were also really interesting and they were great exercise for our mind as well. Thank you very much, sir. We are all really thankful that you
here. Children, please finish your lessons by one period. And from here for 5 minutes, we are going to declare top 16 who are going to participate in tomorrow's quiz. Okay? So within 20, you are having only 20 minutes. Within 20 minutes, please come fast and sit quickly. Okay? सबसे पहले अनुक्रम एक ही है ग्रुप, सिर्फ एक ही ग्रुप सॉन्ग है, मगर लिख दो अनुक्रम और काम डांट नहीं तो मुझे नहीं आता ना बोलना ना, मुझे लिरिक्स नहीं आता और मैं सीख ले। सुनो सुनो आएगा एक दिन में कैसे, हाँ वो एक दिन में कैसे होगा, इधर बताओ और जो भी आता है वो बहुत क्रिंज लगता है। ये दोनों है ना, इन दोनों निकम्मों को लगाओ काम पे, इन दोनों को कुछ करवाओ यार, इसको ऑर्केस्ट्रा भी मिल रही है। हां इसको ऑर्केस्ट्रा मिल रहा है, ऑर्केस्ट्रा सबसे पहले ग्रुप सॉन्ग ये भी डिपेंड करता है कि ग्रुप सॉन्ग वाले कितने प्रिपेयर्ड हैं, क्या मतलब प्रिपरेशन ही नहीं है। ये भी कुछ नहीं करेगा, पहले देखो पहले ग्रुप करवा देते हैं, ग्रुप और कल हम दोनों का सिर्फ एक ग्रुप सॉन्ग क्रिएट होगा और किसी नाम दिया सिर्फ एक कहीं ऐसे ऐसे सोलो है अरे अरे हट जाएगा हर कोई अलग चीज कर रहा है ये चीज तो वही वाले हैं चलो जा यार यहाँ पर आ गई दोनों वाले पढ़ो दोनों का दोनों करा ओ पी तो नहीं तेरा आओ यार खाना लेके नहीं तो कर रहे हो यार कोई बोलने वाला नहीं है शायद इसलिए ऐसा सब है
क्या है चालू है
मेरे बच्चे 20 मिनट क्या बात है सब 5 मिनट ग्रुप सिंगिंग वाला आधा बच्चा आएंगे
दाखवायचं